This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello, everybody, and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber, and it's a pleasure to talk to
Peter Seberg. Welcome back, Robert. 3 weeks of summer holidays.
Summer break is over. Yes, we are back, Peter.
Most of our listeners as well, I think. I mean, we're recording from Germany, where people do have typically 3 weeks of, not everybody, but at least those people with children. The children have a lot longer time, but not everybody from around the world, I believe, does have summer holiday, or maybe they have a lot shorter time. And we typically in Germany, we both, where we live, we are part of the country where people go into holiday the latest, right? So many of you listeners have been back for a couple of weeks.
Exactly. Let's start with the news part, Peter. What do you have?
Yeah, I was thinking myself, did we have any major bang, so to say, over
Major bang?
summer?
Oh.
Yeah, well, one which made the world stop for a second, and I mean it in a positive sense. We're not going to go into all the negative bangs that we had related to AI. So I had one thing which could become a major bang. That's the first one. And then I'm going to have a second topic later on, which is not a bang, but can move into. So the first one I have is Christian Gilchem. You know, we met him at Siemens for Purpose conference, and I interviewed him a year ago. That was kind of the beginning of the agentic process automation. He's the CEO of Embraceable. He founded ACSL, that stands for Advanced Cognitive Systems Lab. It's a privately owned, interesting, and not-for-profit AI. Where did we hear that before? Company based in Karlsruhe. And, quote unquote, because we believe humans must remain in control at all times, and because we refuse to settle for less than machine intelligence that likewise earns our admiration and our trust. Now, their founding...
Sounds a little bit like safety AI or something like that.
Well, in that exactly the direction. So he's going to combine both. Their foundational motivation, most noble guiding principle is combining cognitive performance with structure and control. Yeah. Now he introduced, and that may become a bang. I think he's grabbing for the stars really, a new architecture which he calls Leibniz von Neumann. It's a combination of two names. There happen to be two German names, two architectures. One which is our current PC architecture is based on, right? And he uses those as the basis for what he calls conclusion machines. And then we come to exactly what you say, embracing the strengths of the large language models while overcoming the structural limits. And they are today safety, reliability, right? Enough for now. I suggest that we link to the paper, but I do suggest that we stick close to him and see what is gonna come out of what he's calling the conclusion machines, and that maybe we want to talk to him again. It looks like maybe you and I will see him, talk to him anyway at our Industrial AI happening at SICK in October.
That's interesting. I read something that he combines a lot of LLMs to reduce hallucination. Is that the one point, or was it this?
Most certainly it is, yes. Well, when he talks here about the negative aspects. So he combines the positive aspects of, and which we know, and I'm going to come to that later on in my second point, but first to your points. And then there's a couple of things where we have a problem. Yeah. And of course, it's the same. I mean, and not only in whatever areas where we always need almost like a deterministic answer. And we know that we cannot just by asking the LLM whatever we want, although I must say I'm using mine for more daily routines, and I'm really, really impressed all the time. But if I say all the time, as we all know, it's not all the time. So it's the 99 times. And as we all know, we in industrial and in many, many parts of whatever we do, we need 100. We need a 99.9999. it being impressive and it being correct. And exactly that's what he is looking at combining and giving us a solution for.
That's interesting. So I would like to share, you mentioned LLMs and agentic AI. I would like to share an observation with you, because you remember I worked with the guys there in Linz with the Tyrex model. And a few weeks ago, Alibaba published a new model, and now more and more time series model are coming out. Salesforce has followed. And I've just the feeling, or everybody in our team has the feeling, that there is a momentum in when it comes to time series. Time series are a hot topic, and my prediction is we will see many more foundation zero-shot models in the coming weeks, months. All the big companies are working on them, and maybe it's the next, let's say it, wave when it comes to AI, because now also the big tech companies are going into this time series topic. It was a little bit the smaller brother of the large language models, but now it's a momentum of building new models. That's interesting from my point of view.
Where is Tyrex then there? Because yes, I can confirm that I've seen, maybe not as strongly as you because you're a lot closer, but I see many times, I see posts on, wherever we are, typically LinkedIn. And then I sometimes want to ask this question. I'm asking you, did you guys look at Tyrex? But then I don't do that because I don't want to involve there too strongly. So where is Tyrex standing today then?
Well, SEP is publishing a new version of Tyrex, I think, in the coming 2 weeks. And it's a totally new, it's not a totally new approach, but it's a little bit different approach. There was a discussion in the leaderboards about new rules and new data, etc., etc. So there's a huge ongoing discussion also when it comes to the leaderboards with new rules, new data sets, etc. So there's I think 5, 6, 7 years there was totally quiet. There was not happening a lot in these leaderboards. And now there's a huge rush. Everybody is looking for new models in time series. So it's very interesting.
This sounds very much like, taking our listeners back, 30, 40 years ago. Yeah, it's the 1990s. And that was the time of, Intel 486. Have you ever heard of that one? And then the first one you may have heard of is Pentium. And that is the time when, and I'm going to come back later on to AMD as well, because I'm going to be talking there to Jens soon. And that was the time with regards to the performance of microprocessors. And there were all these different, what you call leaderboard, different ways of how do I measure performance. There was a lot of fighting backwards, forwards. Oh, well, if you do it this way, it's good for you.
You can call it the time series wars now.
Something like that. I haven't seen those, but I did hear about it. I think what you're referring to was exactly the same. What is that? Probably 40 years back was for the microprocessors, is today for measuring. And yeah, I mean, at the very end, I looked just this morning again at where the different models are. And that's, of course, exactly the same thing. Whatever of kind of way of measuring you're using, one is better than for the other.
Exactly. And we will see the same as we see in the language field. I think we will see the different. There will be a race between the big techs, and there will be some smaller companies, and with different approaches, we will see exactly the same development there.
Well, looking forward to see the updated Tyrex version by SEP.
Yeah, absolutely. What else do you have, Peter?
Yeah, I only had one more. I mean, it's not too much, but I did look back, and this is one I believe it's worthwhile talking about. It's not a big bang as such, but I believe it's a sign of a structural development that may end up in a really big bang for society. So young people, recent graduates, right, not finding a job. We heard of it, I believe. Now there's kind of a confirmation by a Harvard study. Only read the introduction, but confirming it because of a lack of entry-level jobs at companies adopting Gen AI, right? On one hand. Now I'm going to combine this with, on the other hand, my friend Andrew Wang talking about the unmet demand for developers who understand AI. So, he talks about more, universities, they have not yet adapted to their curricula, right? That's Yeah, I understand that. So specifically for computer science, refers times way back from programming by punch cards. Yes, I was there to the keyboard and terminal. That was amazing for me personally. That was a thousand-fold step in time performance. But I'm not going to go back. But he just says like also, and he is, I don't know what age he is, but maybe he was there himself. And he says employers continue to hire punch card programmers, right? But in the end, of course, everybody had to switch to the new way of doing things. And that is where, of course, he's saying, AI engineering is going to create this huge change as well. In the end, I think he is saying that there's this quote that people love: you can't just vibe code your way to greatness. The basis of, in this case, studying computer science is still very important. Now, I agree with him that we see that folks with deep knowledge in artificial intelligence are being offered huge salaries, right? It feels to me like similar to football, soccer leagues, right, around the globe. Whenever we have a discussion here, and we do have a soccer team in the city I live close to, Munich, but all the other ones, and I'm not into it at all, but I hear the amounts of dollars or euros that they get, right? But on the other hand, what I feel a lot more of an issue is the question of, is AI taking over the entry level jobs? And is that just a start of call it a big bang at some point in time? That's what I see happening. And I was just a couple of days back sitting there meeting my old friends from the choir. There's a young guy. Oh, what you doing? Oh, yeah, I'm starting studying. And what can I tell the person? Make sure that whatever you do, that the AI element or all the opportunities that you are given at your university, take them as much as you can, because that's what's going to help you when you're going to be ready, when you're going to be coming back to work in society. So and what I hope is that, again, referring back to our conference at SICK in October, where we're going to have a pre-session with Thomas Hurt, right?
Yes, exactly.
And I hope that Thomas, isn't he exactly not sharing his experience on one hand, how do we get the best people? But I assume, I'm not sure if you know that he, for the same reason, can also talk about what he sees happening on the entry level. If he, from his research, can confirm, what does that do to the market? I mean, we had a certain people at the entry, at the middle, and people are very, very skilled. And how is that changing? And what does that do to our world?
That's interesting, because you mentioned Bayern München, and there's a German saying. I remember when I was a child, my father always told me, money doesn't score goals, because Bayern München bought every big player in the field, in the world. And is that still true? And I don't know. Yeah, but they was very successful at the end, Bayern München. Yeah.
I was almost going to say, and then you go back to, if you just look at correlation, the old saying, and the old saying, that's again related to Christian Gilcher, because then we go to causation, and then causation in the end. So is the causation the fact that and that's always the question I hear, although I don't concentrate on it. Is this one person they just bought for $100 million? Is that person worth the $100 million? And as you say, if they do that 10 times and they put $1 billion and they have a team of 10 plus 1, 11 players plus many other ones, and they win and win and win, maybe there's more than just correlation. Maybe there is some causation, right?
Exactly.
Yeah, and I don't know what to say, right? I don't know what to say. At the same time, I didn't get into the details. Trumpf, the metal sheet machine builder company, I saw this wonderful team of, I believe, 10 people. And then they had another huge thing around summer with so many people, maybe everybody learning AI. Really loved this idea in difficult times, educating people. And then the team who is going to continue to concentrate exclusively on. So, yes, certainly there are opportunities. That was a team of mainly young people I saw. So I think there's opportunities there. And I hope that we're going to find a solution for those instances where maybe times are difficult.
But I need to add, but AI makes it even possible to achieve something by yourself. So you don't need the big infrastructure topics. So I think that's maybe we have a discussion on DeepSeek, but yeah, you can see that there are people coming together. They are not big stars, no big conference papers. And then there was this moment, and then we had the DeepSeek moment, right?
Yeah. So that's the idea of, instead of you as a person who initiates a startup, you're going to start with a friend or there's 2-3 friends. And then a couple of months later, you are being financed, you're 10 people. Then a year later, you're 50 or 100. That idea that you could do in specific instances by yourself, running this 100 company all by yourself, right? But even in that case, that's only going to work if that one person is really representing a potential of 100 people. Just to stay at that theoretical idea, does that mean that the other 99 people are not going to get a job? Or do we expect those other 99 people to do the same thing? And the theory says that if, use the potential of AI and we're going to grow and things are going to be amazing on one hand. And on the other hand, if companies use the potential of Gen AI specifically, and for that reason not employ, young people coming from university, then that's not good, right?
Exactly. I have another tip, Peter. If you want to know more about diffusion models, our friend Jakub Tomczak has created a course on the subject. It's very cool. I already did the course. Very interesting. Yeah, and Jakob is coming from the beautiful San Francisco, you already mentioned, to the Black Forest for AI in the forest. And I'm really looking forward because he's, what you call him, the Pope of Gen AI systems, right? You called him the Pope.
Yeah, I'm not sure that but we mean it in a very positive sense. We don't want to say in a negative sense close to people that are religious. But I'm not sure if we use it in English as well, but at least in German, we say if somebody is really good in a specific area, we call him the Papst or the Pope of, without being negative in a religious way. Yes, he was very, very proud of that saying, actually. Now tell me, is that not too technical?
It's a bit technical, but it's a bit technical. I will share it with you after the recording, and then we will share it with our listeners. But you can feel Jakub is a researcher, but he's also a teacher. He also wants to explain things to the people. And when you read, he published his famous book. You talked about the book with him in the first podcast, I think, and very famous book on Gen AI systems. And yes, he's a researcher, he's a smart guy, but he's also a good teacher. And I will share the link to the course. It's free on his website. Everybody can have a look at diffusion models.
Very good. Yeah, looking forward to meet him. Looking forward to great discussions with great thinkers, with people looking further from where we are today, looking further into the future of what is possible, looking behind the technology, as you just shared with us, diffusion, or looking also into the future of making sure that whatever we're building is going to be, giving us correct answers 100% of the time. And I think it's important as well, making sure that we're all going to have something out of it as a population, as a world, so to say.
Do you have anything else?
So just in the end, I am. There was a lot of discussion. In addition, I believe MCP, I'm not going to go into the details. We had a GPT-5 discussion. Forgot that already. I looked this morning, as I said, I typically look at the LM Arena leaderboard. That's
And you
another
see,
one.
leaderboards.
Yeah, there you go. And I'm not sure what the people are maybe saying of that one in the discussion you just referred to, but their Gemini 2.5 has crossed back over from GPT-5. It's number 2. That's the level I look at every Sunday, kind of, just to get a little bit of a feeling who's doing what. Then it was loads of MCP. Also, and again, specifically in an industrial setting, which of course we do not forget, that's where we come from. That's what we are here for you. And I would like to talk to Armin Hatzalic again from Siemens.
Oh, that's your friend. Armin is your friend now, your MCP friend.
Yeah, it's very good. I think somebody else was suggesting, forget his name, maybe we come to that, MCP is not going to make it. Armin has his good reasons for saying MCP is going to make it at the moment. I'm with him, but let him explain, let him tell you why he believes so. And before that, I'm going to be talking to Jens Stapelfelder at AMD, and he should be telling us how AMD is going to crack the NVIDIA CUDA lock on the market.
That's interesting. And you already mentioned Gemini, and now I set up an interview with Philipp Lippe. He has now the approval to talk to us, because at Google it's always a little bit difficult, but he's a part of the Gemini team, and we already talked about the German Wunderkind, and we will record an episode with Philipp. Yeah.
Oh, wow. Looking forward to. He's based in Silicon Valley now? Or?
He's based in Silicon Valley. He was part of the banana topic of Gemini. So banana is his topic. And I'm really looking forward to record an episode with Philipp.
Great.
And I have one surprise. Don't know if you recognized it, but Neurops is coming to Europe.
Oh, yeah, I saw that.
Yeah.
To what city? In the north?
Copenhagen.
Copenhagen.
Yeah, there will be a European version of Neurops. It will take place at the same time as a conference in the US, and it will be in Copenhagen. So there's a big chance for everyone now to join in Copenhagen, and I'm really looking forward not to travel to the US, to the long flights, and to travel to really? Copenhagen. Yeah.
Oh, is that the idea? That's what you will do? You will go
to we will go to Copenhagen, and we will have a booth there, and etc. Yeah.
Oh, right. Are they connecting the two together, like, video connection or whatever, or is that the idea?
Yeah. You can still travel to the US as a first author, but if you are accepted, you can also present your paper in Copenhagen. And there's also a third location. It's Mexico City for all the guys who have problems with visas. And you can also go to Mexico City. So on one hand, it's very good to have a European version. On the other hand, maybe we will have different areas now, different continents. Normally, the whole research community is coming together at Neurops, and from all around the world will be there a split between the research communities. I'm not sure, but I'm very happy to travel to Copenhagen. It's a wonderful city.
We can discuss with Jakob as well when he's there. He's still involved, I believe, right? So I think as long as we're allowed to communicate by ear or by eyes digitally across the world, that's good to start with, I think. And maybe sometimes, I think you talked about, as you were there last year, maybe sometimes the rooms are so filled that you have to go to a second room and you look on a video screen, right? So if that is the case, looking at the video screen, you cannot know, or it doesn't matter in the end, knowing where the person sits that you see on the screen, right? So I think as long as they make these connections, but I'm not going to go into the details of telling the people from Neurops what to do. Hey, looking forward to, who knows? Haven't been to Copenhagen for a long time.
Yeah, Copenhagen will be an option for you too.
Yeah, most certainly could be. Yeah.
And I think it's a good sign also for Europe to have own, let's call it own Neurops in quotation marks in Copenhagen. I think it's a good sign. Alice is pushing this very good, and I'm really looking forward.
I could imagine that industrial AI is going to be maybe a relative bigger share of the topics than in general
Yeah, and it's
neurostructure.
a chance for our mid-sized companies, for our Arburg, Six, I don't know, Harting, Phoenix Contact to send their research guys to Copenhagen to get involved in the whole discussions what is happening in the research community. Yeah.
Okay, well, we'll keep you up to date.
Oh, that's perfect. Let's switch to the main part, Peter.
Yes, what are we listening to today?
Yeah, from Copenhagen to Paris, I did an interview with Victor Schmidt. It's a German name, Schmidt, but he is originally from France. Then he moved to Montreal, to Miller, doing research there with Bengio on climate change, AI. And we already had an episode with him, I don't know, 3 years ago when he was a researcher at Mila. And then he went back to France. He will tell us why. And he founded an own company and now is doing AI for new materials. So very interesting approach. Yeah.
Sounds like CASP, no? Something
Exactly.
similar, no?
There's a big competitor called CASP. We already did an episode with Max Welling on this topic, but the market is so big that there could be two companies.
Oh yeah. There's always need for a number two. I mean, yeah, I wasn't suggesting that one of the. I mean, competition, same as what you referred to before with time series. Competition is always very good for additional new developments in the market.
And it's very interesting because Victor is sharing also why Paris is so fascinating, why the spirit in Paris is different to the spirit in Germany. When it comes to AI, a lot of money, investments, and Paris is becoming maybe the one powerhouse of AI in Europe.
All of them want to be the number one. Amsterdam wants to be Paris, and then I
Zurich.
refer back to. I'm not going to ask you again for the list that Sepp shared 2 years
Oh
ago.
no, please.
No. And maybe that's different. All of them want to be, and most certainly, we hear Paris many times. Started with Macron, is the president. When was that? A year ago, half a year ago, I guess.
And GTC is in Paris, right? So yeah.
Yeah, also.
Yeah.
There you go.
Very interesting episode with Victor. Listen to him now. Thanks a lot, Peter.
Thanks, Robert. Talk to you soon again. Thank you, dear listener, for having stayed with us, and enjoy the next episode. Bye-bye.
Bye-bye. Hello, everybody. My name is Robert Weber, and my guest today is Victor Schmidt. Victor, welcome to the podcast.
Hi, Robert. Thanks for having me. It's a pleasure to be here. At last, I would say.
Yeah, at last. Yeah, back then you were still at Mila in Montreal with Benju. I think 5 years ago we recorded an episode. Now you're in Paris with your own company. What happened in between, Victor?
That's indeed quite some time. So what happened is that my initial focus during my PhD was to work on deep learning applications to climate change mitigation. And I started with generative models for vision, actually, and trying to elicit emotions, empathy, and enable people to protect themselves in the future when potentially disastrous events could happen. And so basically simulating images of climate change so that you could visualize what a flood would look like at your own place. And then I transitioned towards a different kind of deep learning application to climate change mitigation, which is the application of graph neural networks to materials discovery. And again, generative models in the background to enable discoveries.
And you have your own company now.
Exactly. And so during that research, I met with my co-founder, Alexandre, who is doing his own PhD on graph neural networks. And so after all this work, a couple of years of hard work, publishing a couple of papers, we decided that it was time to scale that ambition to the real world. And arguably, the main drive for us to create a company was that we wanted to have great minds 100% of their time contributing to this problem from different backgrounds. And that is pretty difficult to set up in an academic setting. In academic collaborations, you have basically PhDs who do the actual work, and the incentive structure is just not there for you to have, several. You could argue you can have 2, 3, but it's difficult to have a dozen such skilled people work on the same project. So we took a kind of a leap of faith a bit more than a year ago, alongside Mathieu, the CEO, whom I had known for 10 years. And here we are.
And you founded Entelpic, right? That's the name of the company.
Exactly. We created Entelpic a year ago. We raised 8.5 million euros in seed round.
Wow. Congrats.
Thank you. An A team of people from, very different backgrounds, computational chemists, experimentalists.
We will come to this topic later. I want to chat with you with domain specific knowledge, etc. But let's stay with your company first. What does your company do? What is the business model? What is the idea? Which customers do you want to address?
That's a great question. So what we do is discoveries. So our goal is to focus on IP based.
On patents.
And patents, indeed. And so be it for our clients or importantly for ourselves to have both discovery pipelines that basically, research as a service framework, or industrial companies that focus on industrial chemistry topics in general, material science, but not only. And also to have our own discovery pipelines to basically do our own discoveries, have our own patents, and not just sell, the usage of our pipeline.
Mm-hmm. Can you dig a little bit deeper? What do you do exactly when you talk about IP? Is it to find new materials or is it a Gen AI approach? Can you dig a little bit deeper?
So you can think of us as a biotech trying to discover new drugs. So in our setting, we don't discover, organic molecules for cure disease. We apply our generative pipeline to discover new formulations of other things like materials, but it could also be polymers or solvents or electrolytes. There's a bunch of applications there. And so the generative part right now has recently changed a little bit when you think about generative AI. Or for a lot of people, it means currently it means LLMs. Maybe it means diffusion models to create images. What we really mean by generative AI is a search method. The point is that there are so many configurations of potential materials that you can't just exhaustively search. Random search has no chance of discovering something in a space that is, depending on who you listen to, the space has 10 to the power 40, 60, or even to 100 options, depending on the different problems that you look at. So you have to search intelligently in that space. And generative AI is about that. It's about modeling the distribution of the objects that you care about and being able.
So it's a huge database. It's a database technology.
There's a database approach, but it's mostly a search. It's mostly an algorithm. And the point is to say you want to be able to sample from a distribution that you don't have access to in a closed form. So the distribution can be, if you want to have stable materials, and there's a lot to say about what are good proxies for stability, but let's just say that the formation energy of a material does the deal for you. Then what you want is you want to be able to generate, create, and propose materials that have a low energy, and you have to search in the stable possible materials where they have a low energy. And so this is really a search problem. It's in the framework of the scientific method. This is hypothesis generation. You want to try and formulate hypothesis of what could be a good material, and you want to go beyond random guess or substitutions or simple heuristics. You also want to be faster and more scalable than human experts.
Mm-hmm. Exactly. So can you share a bit the AI-driven approach? What kind of data do you use? It's a multi-model approach, or is it? Can you share a bit from a technical point of view?
Yes. So the core of what we do leverages GFlow nets. So GFlow nets are a specific family of generative models. GFlow net means generative flow networks. And you can think of it a little bit like reinforcement learning. So you have an agent, so that's a neural network.
With an agent, yeah. Okay. Mm-hmm.
That is going to take actions in an environment. And so those actions can be something like, I'm going to put an atom here, I'm going to put another atom there, and so on. I'm going to use those symmetries. And there's work that we've published called Crystal GFN that explains how one way that you can parameterize these environments. But the gist of it is that you have a neural network that takes actions, that proposes elements, that proposes how to describe a crystal, and in the end, when it has finished proposing a structure, it gets a reward. And that reward is the proxy that I was mentioning earlier. If you want something stable, you can think of formation energy or energy above the hull. And so that gets a bit technical because it gets domain specific. But in the grand scheme of things, an agent proposes a structure, it gets a reward, and then it learns to propose new materials proportionally to that reward. And that's a key difference with traditional reinforcement learning.
But how accurate is this approach or this solution?
That's one of the motivations actually of GFlow nets, is to be able to not rely too much on the accuracy of your proxy, of your reward. If you had a perfect reward function, then what you would want is you would want to maximize that reward function. You would want to have the most stable crystal. But you only have access to proxies, to approximations of reality. And that is why you don't want to put all your eggs in the same basket. So you want diversity in the sampling procedure. You want to be able to generate a diversity of structures, of objects that you care about, such that in the end, when you sample from your algorithm, when you generate new materials, then you don't optimize for one thing. You have several options, and if your reward function has some bias or some artifacts in its landscape, then you don't have to redo everything, right? You have a diversity of options that you can evaluate with something that has a better accuracy. For example, using simulations like density functional theory based methods, but you could also think of experimental evaluation by trying to synthesize, characterize, and test the objects that you have sampled, that you have proposed.
Okay, you already mentioned IP and patents. What data do you use? So can you talk a little bit about the source?
Basically, with this reinforcement learning-like framework, you need a lot of interactions with the reward function. To have that, to have speed, then you need you need an AI model. And then the bulk of your question is how do you train that reward model, that proxy? In our case, we use DFT data. So density functional theory, family of methods that try to approximate solutions to the Schrödinger equation in order to be able to compute properties of atomic systems. And so this is the ground truth that we use. But we obviously know that this is still a model, this is still an approximation of the truth. And so that's why we also contract with experimental labs in order to be able to go to the real world and make the things. And so the first proxy that we use is trained to approximate density functional theory. But then based on samples that we obtain, we can go and test in the lab, and then we can inject that knowledge from the real world into our training pipeline and improve.
How do you inject this knowledge from the real world?
There's multiple ways you can do this, but one of the ways is that you can replace the reward that you had used by something more informed by what you had. So that can mean several things, but if, for example, you have a search process, you want to generate new materials for a specific application, then instead of using the computed property with DFT, you can use the experimental test of that material as the reward. And so then the IP kicks in when you do a discovery. And so obviously we're not there. The company is very young. This is where we want to go. What we do is we don't do a platform where someone can just come in and just click play and it works. It's very difficult. Training generative models is difficult. Embedding the right domain knowledge is also difficult. And so we don't think this is going to be a plug and play thing where people have a software access. This is why, for industrial companies, what we do is more research as a service.
Okay, so it's a research as a service. So this is your business model then?
Yes.
Okay. Which customers do you want to address with this approach?
It's a good question. We want to address customers that have basically an industrial chemistry focus. So it can be batteries, it can be PV, it can be manufacturing of chemical products or cement. The important factor for us is that there must be an environmental impact.
Why is it so important for you?
That's one of the drive of why we're doing this.
Okay.
That can mean having an impact on enabling new technologies that are more sustainable. So I'm thinking about, for example, grid scale batteries or PV, but it can also be about improving the manufacturing process of chemicals like ammonia production or cement production. But it can also be things like depollution. It doesn't have to be only climate change, all sorts of environmental impacts. What we care about is having an impact, a positive impact on the world, and this is why we're coming together.
Mhm. You already mentioned domain-specific knowledge. How much domain expertise do you need now when, for example, you talk to a PV company and they want to do research as a service with you? How much domain expertise do you need in your team, and how do you bring the domains then together? Machine learning, the domain, PV in this case, and then the domain knowledge into your research. Can you explain that a little bit?
Yes. So in our framework, domain knowledge comes in two specific parts of what we build. One is the environment. The environment is basically the rules of how to build an object. So sometimes when you select a crystal, for example, once you apply symmetries, then you have to put atoms in specific places because of symmetry. And so those are mandatory actions that you have to take. That's where you can intervene. But sometimes you can also prevent things from happening. You can say, in this state, you cannot take this action. And the nice thing about this framework is that there is no hypothesis on the rules. You can just say that something is attainable or unattainable for any reason. You don't have to make this constraint differentiable or continuous, or the network doesn't have to understand why it's unattainable. And so you can intervene there in the rules of the environment, in the constraint of the generation process. That's very important. And the second thing is that, well, this whole process relies on a reward function. And so domain knowledge comes in there too. You have to define your success metric. What do you care about? It can be a multi-objective optimization. Well, it's not optimization, but that's for the sake of the argument. We can have several objectives that we want to try and satisfy. But in the end, the customer knows what they want. And our job is to try and translate what they want into our tools. And that's the role of the computational chemists and material scientists that we have on the team. Try and be the bridge between the research problem of our client and the algorithmic capabilities that we build in our platform.
You mentioned your business model, research as a service. Can you explain me a little bit the process? Maybe I'm an owner of a chemical plant. I want to do research. How do we handle it now with your company? Can you explain it a bit?
Yes, it's a great question. Basically, we're an AI company, and so the one thing that we need is data or simulation capabilities. Our first step is always to try and map the data landscape. What data exists either out there or at the clients or in our own private data.
So you need data of my product, of my production process, etc.
Well, you need a way to stimulate your success metric, however that works. And so we can learn this if you have experimental data, for instance. We can simulate the process oftentimes, run DFT. We have high throughput DFT workflows in order to generate the appropriate data. With active learning in order to create predictive methods that work well for your use case. And so the workflow is usually this way. We first start with gathering and generating data. Then we train predictive models, GNNs, either fine-tuning pre-existing methods or developing brand new ones for our clients' needs. And then we use this predictive model in an active learning loop with the generative model that proposes new structures. And then we measure a bunch of things in the acquisition function, like expected improvement or uncertainty of the model, to try and improve the quality of the predictive model, because the generative model depends on the predictive model. And so that's a positive reinforcement loop, right? The more you do this, the better the generative model. And in the end, well, we run, once everything is trained, we sample. And then we can rank structures, there's a bunch of things, and it all depends on the application. But if you're an industrial company and you want to either discover brand new things and you want a brand new material for a layer in your system for whatever, or if you want to explore modifications like defects and so on, then that's also something that we can model, that we can explore. And it's basically the ideal scenario is when you have a good way to measure the success, but that way is expensive. And so you want intelligent in the way that you test your hypothesis. And that's where the efficient search of a generative model can really kick in.
Okay, I got it. So let's think now, research as a service is your business model. Is there maybe a pivot in the next years that also domain experts can use your approach as a tool, or it is impossible for them to use it?
I can't say that it won't happen, but it's not the plan. Our plan is to develop those tools for our clients and for ourselves. Now, we don't evolve in a vacuum. We do research, open research. We have scientific collaborations with diverse universities. We have industrial PhDs with Talpic, with French and British institutions. And importantly, we give back to the community through our initiative called Le Material. This is a joint venture with Hugging Face, and we want to basically iterate a community at the intersection of AI and material science and computational chemistry. And one great avenue for this is structuring and leveraging data. So that's why our first release back in December was around aggregating existing data sets. So especially with the groundbreaking work and the foundation of those modern methods, which is the Material project out of Berkeley, plus other data sets like OpenMD and the great work by the Alexandria folks, and basically collecting those data sets, creating splits of these data sets that are coherent from a material science perspective, but also available through Hugging Face data sets so that they are machine learning ready. And that's how we want to bridge the gap between those communities. And that's how we give back to the community. And whether our generative models will be part of what we give back, maybe, but that's not the plan. I think the most training generative methods is very difficult and it's very problem specific. And I don't think that's the most, I would say, generalizable way back to the community versus developing data sets, releasing data, and federating. That being said, we do work on evaluating generative models because this whole field is so dynamic that a generalist model might be the best today. It can be beaten by someone else tomorrow. When you need a way to benchmark those things. You need a way to compare. It's pretty standard for supervised learning tasks when you want to predict things. Much more difficult when you have generative tasks. And so our goal is to help the community develop better, evaluation metrics and benchmarks. And we do that within the material community.
Let's talk about Station F or Station F in Paris at the end. Why did you go to Paris and not stay in Montreal with your company?
It's a great question. So for one, we haven't completely left. We still have a presence in Montreal. We still have a collaboration with Mila. We're still partly there, but it is true that we decided to start the company here in Paris. There's several reasons for that. First, the three founders are French, so it's kind of a big bias. And after staying in Montreal, I was happy to be back in France. Second, the AI ecosystem here is super dynamic. There's a lot of great talent. There's a lot of people who are existing talent in Paris, but also it's a pretty attractive hub for AI and for scientists. And I think we wanted to rely on the European ecosystem, the European talent. There is something of a sovereignty feeling. We want to build on this ecosystem, and we also want to give back. The three of us have been lucky enough to be educated in a very good free system here in France, and there's also this feeling of giving back and developing both the industry, but also the research environment here in France. AI is a very hot topic, and there's a lot of support. And indeed, Station F is also a great way to start. When you have nothing, you have just three founders, not having to care about all the logistics that come with having an office and so on. That's a big plus. And we were incubated also within Station F by Central, Central 21st, which is an incubator of the Centrale University and in engineering school here in France. That has been very helpful for us to start. And honestly, Station F is a great environment for us, also because it allows us to grow.
Okay, great. Do you have open positions in the moment?
Yes, we do. The most stable in time way to answer this question is to say that those positions are online. You can visit our website, entalpic.ai. You can follow us on LinkedIn, and we will post those job applications. But currently, we're looking for material scientists, and data engineers, and there's a lot of work across the board at Entalpic, engineering, science, but also business development for people who have experience in this industry. So the best way to get to know what are the open positions at Entalpic is to visit our website and follow us on LinkedIn.
Victor, it was a pleasure. Thank you very much. After 5 years, you had a long journey, but it sounds very interesting. We are keep fingers crossed for your approach. Thanks a lot. Greetings to Paris.
Thanks a lot, Robert, for having me. It was a great pleasure to discuss with you. It was very interesting, and I hope we do that again.
Yeah.
Let's see next year.
Let's not wait 5 years.
Yes.
Thanks. Bye-bye.
Goodbye.